Hello class, my name is Wallace, and I am in the United States Navy. I am a Master at Arms, which is military police, and I am proud of what I do every day. I am in Intro to Physics, and let's start learning. When we start our experiment, we will start off with iron and make the mass of iron 100 grams. And we'll make the temperature of iron 100 degrees Celsius. And we will make the mass of water 100 grams. Make the temperature of the water 20 degrees Celsius. Once we have finished, we will hit start to get our final calculations. As you see, the temperature will rise up. And we'll get a final temperature of 27.82. We have the specific heat of iron is 0.452, and we have the specific heat of water, which is 4.18. Once we have gathered all of our data, we need to calculate the heat loss by the metal using mass times specific heat times temperature. Once we have our formula, we will break it down just a little bit more, which we'll keep our specific heat times mass, and we will break temperature down by having final temperature subtracted by initial temperature. We will calculate the heat gain by the water using our same formula. I will write down the specific heat, which is 4.18 times 100 grams times our two temperatures, 27.82 degrees Celsius, subtracted by 20 degrees Celsius. Once we do our math, we get 7.82 degrees Celsius, and we'll times that by 100 grams times 4.18, and that will give us 3.3 times 10 to the third joules. Once we have our final formula, we will plug our numbers in, which we have 0.452 for specific heat. We have 100 grams for mass, and for temperature, we have 27.82 subtracted by 100 degrees Celsius. We will break down our math equation a little bit further, and we will get negative 72.18 degrees Celsius, and we will times that by 100 grams and by 0.452, which we will get a negative 3.3 times 10 to the third power joules. By comparing the final answers of the heat loss, negative 3.3 times 10 to the third power joules, and the heat gained 3.3 times 10 to the third power joules, came to a conclusion that the two are almost the same. The answers are complete opposites of each other. We knew that the heat loss would be negative because the final temperature was very lower than the initial temperature. There is no errors in the experiments because the answers came out how they should be. For our second experiment, we are going to use the metal X, and we are going to make its mass 100 grams, and we will make the temperature of metal X 100 degrees Celsius, and we're going to make the mass of the water 100 grams, and we're going to make the temperature 20 degrees Celsius. Once I hit start, we will be able to find our final temperature, our final temperature is 28.71. Our specific heat is unknown, and our specific heat of water is 4.18. We need to find the specific heat for the unknown metal, which would be specific heat equals heat added over our mass with our delta T, which is our temperature. We need to break this formula down further because we do not have the heat added, which we will be able to use the water equals the mass of the water times the specific heat of the water times the temperature. With our formula, we will plug in our numbers. We have 100 grams with 4.18 times 8.71, and that will equal 3,640.78. Now we will be able to use our formula. We will take 3,640.78 over 100 times 28.71 minus 100, which will equal 0.5107 joules over GK. Once we gathered our number, we will look at our chart to find the closest number to our answer, which will be titanium, closest to 0.5226. In conclusion, we are able to have a better understanding on how to use a calorimetry and be able to see how heat is transferred from metal and water.